Okay, so now we'll be looking at question number 3. In question number 3, we are, as you can see in the question, we are given 1% of adults in a certain country owns a yellow car. We have to first of all use a suitable approximating distribution to find the probability that a random sample of 240 adults includes more than 2 who owns a yellow car. And in second question we have to justify our approximation. So it's very simple, right? We are given that probability of yellow car in a certain country is 0.01. And we are also given the number of trials or the sample as 240. Now, how do we understand which approximation to use in this particular situation? Okay, so we could have done, the first thing that comes to your mind is a binomial distribution. And of course you could have done using a binomial distribution here. But the question is asking us to use a suitable approximation which can in which we can find the probability of x is greater than 2. Okay, so in this question we use Poisson distribution. Okay, now why do we use Poisson distribution here? Why not normal distribution? As you can see here, the value of mu is 2.4. And if you want to use a Poisson distribution, if you want to use a normal distribution, your mu has to be greater than 5, right? So if mu is not greater than 5, you cannot use normal distribution. That's a rule of thumb in case if you want to use a normal distribution. Now, as you can see, for Poisson distribution, the probability has to be very low and the number of trials has to be very high. Okay, so if you have a binomial distribution, with number of trials n and probability of success as p, then the probability here has to be very low and n has to be very high if we want to use the probability, if you want to approximate the binomial distribution to a Poisson distribution. And also because n is greater than 50, we can say that we can use Poisson distribution here. Now, so in any case, so now we know that mu is np, right? So n is 240, so 240 times 0.01. And similarly, the variance is 2.376, although we do not need a variance here. So using a Poisson distribution here with lambda as 2.4, because mu is also lambda, then we use a Poisson distribution formula to find px is greater than 2. So px greater than 2 simply means 1 minus px is less than 2, right? So in this case, p of x greater than 2 simply means 1 minus px is less than 2, right? Equals to 2. So then for this one, it gives us this. So finding each individual values here by putting in the Poisson distribution formula, we have 1 minus 0.5697, and therefore your answer is 0.430. Now the second question is basically asking us to justify our approximation. Okay, so how do we justify our approximation here? Okay, first of all, in order for you to approximate a binomial distribution to a Poisson distribution, we must have a fixed number of trials. Okay, in particular, you can approximate a binomial distribution to a Poisson distribution for n greater than 50. This is a rule. Okay, in this case, each trial is independent from one another because we cannot say for sure an adult from a certain country will definitely have a yellow car. So it's independent from one another. And also, the third justification would be probability is fixed for a given location. So in this case, this country here has a fixed probability of success, right? So we are assuming that 1% of the adult in a certain country owns a yellow car. So if the probability is fixed and the trials are independent, and also if the trial is greater than 50, we can definitely say that Poisson distribution can be used as a suitable approximation. So that's it for today. I'll see you in the next question.